thank you everyone who is here. Marike and I, we're both part of the DH Lab of the Carnegie Humanities Cluster in Amsterdam, but we're also part of the Cultural AI Lab, of which you see the logo here, which is a sort of a lab that tries to foster AI research, but sort of with an eye on, with a special eye on cultural applications, but also the other way around. So trying to let culture and cultural stances flow back into AI. And it's a collaboration of some of the organizations that you see here. So for instance, the CWI in Amsterdam, the University of Amsterdam, but also cultural institutions like the Rijksmuseum or the National Library. My project, or Marike and my project, is called SABIO. We've been doing it for the last 1.5 years. And SABIO is a shorthand for a social bias observatory, which was funded by the Digital Heritage Network in the Netherlands, and which we are doing in collaboration and on the collection of the Museum of World Cultures of the Netherlands, which was founded, I think, in 2004, when the Tropenmuseum here in Amsterdam, the Africa Museum, the Museum Volkenkunde, and the Wereldmuseum, 4 museums in the Netherlands, joined together their collections, and specifically the digital collections, and made one large collection out of it. And then now they're also sort of coordinating their activities a bit. Right, so we have been developing the Social Bias Observatory specifically on their data sets and also in collaboration with them. So, which means that we've also been having quite a bit of back and forth on what are their needs, how would they like this project to be shaped. So let me start with how are they addressing the biases in their collection. The NMVW is the shorthand for the National Museum of World Cultures. And so while the title of this presentation is Inclusive and Responsible Design, I would like to use the biases, so the sort of the central topic of the SABIO project, as an example of how design of computational tools on collections could be done. And so this story starts with how is the museum itself addressing these biases. And so a first step has been taken by the museum itself. And I think it's one of the first steps in this direction by any Dutch museum, by the publication called Words Matter, which they published in 2018, which is a lexicon, and it's also explicitly always unfinished, on word choices in heritage collections. So what they did is they asked all the researchers on the collection, the ones that sort of try and find and explain and understand the biases in the collection on a daily basis, they asked them to just bring together all of the words that they find on a daily basis, the words that they come across, and then put them in this publication, where they also added explanations on why is this term problematic, which context does this term occur in, and some preferred alternatives if they do exist. This is not very well visible, but in the middle I put the object cards for 4 objects in the digital collection. So if you go to the public to the public interface of the digital collection, you can actually find these cards back. And these are just examples of the kinds of biases that we find in this collection, because the thing with this collection, which I maybe forgot to mention, but which maybe was also clear, is that heritage collection in the Netherlands contains vastly colonial objects, right? With the colonial history of the Netherlands, most of the biases, most of the problematic terminology, and in general, most of the phenomena that you might find in this collection are of some kind of colonial nature. Not all of them, but most of them. And so, for instance, what we see on the right-hand side one example that I find quite fitting is a drawing, and what's quite notable about this object's description, actually, which you see here on the right hand side, I'm not sure if you can actually read that, is that the description doesn't really mention the two people of color in this object. The woman is mentioned with just half a sentence. The boy is mentioned only sort of in a sentence by what his function to the white person in the picture is, and the white person is actually described with, I think, 3 paragraphs of text. So this is just one of the examples of the types of biases that you can find in this collection. And why I'm bringing this up is because biases in this collection can and often do go beyond pure word choices. So that's where the Words Matter publication, to me, and this is also something that we also found out together during this project, is a very good first step, and it's a very important first step. But it also sort of misses a lot of the biases that can go on in this collection. Similarly, with this stamp tool down here, it was actually used to brand enslaved people. And again, the description doesn't mention that. It's just a technical description of what that tool is and what it consists of. So again, the bias is kind of more subtle, more in you need a deeper understanding of both the object and the description to really see where the bias is. So it's really not just about, as you might think from the Words Matter publication, not just a simple sort of find and replace to address biases in collections. And I am really saying this because some people seem to think that that's what it is. I'm also saying this because if it was just a simple find and replace, then even with the large collection that the Museum of World Cultures has, it could be fairly simple, right? Because on a digital collection, find and replace is fairly straightforward. But because this is not so, researchers would technically have to go through objects sort of piece by piece and do this by hand. But then this collection has more than 800,000 objects, at least the digital one, the physical one, I'm not actually sure. I think it's a few more. After what I call cleaning, so I got my hands on this data set, of course, to work with it, and then I had to clean it for various reasons that are not part of this presentation. There's roughly 140,000 objects left, but this is still way too much to be considered by hand. The reason I'm bringing this number up is because it also gives you an idea a bit about how complex and messy this data set is. There's a lot of objects where information is missing, where information is not quite consistent or coherent. So this is also what I mean by cleaning. So just to give you an idea that this data set is also sort of, as a data set, quite complex to deal with. This will come up later again, I think, in the presentation. And we have roughly 7.3 million words in the titles and the descriptions of objects, which makes for 300,000 unique words, so a vocabulary of 300,000 words. Now, the Words Matter publication, I think, consists of 90 words at the moment. So I think this can give you an idea of what kind of scales we're dealing with. And yeah, as I said, or as I tried to make clear, these researchers, they really have the scale of what they're dealing with is this. And not just this, but also the sort of the full complexity of the past, because in a lot of cases, you also have to have sensibilities as a researcher as to, you know, the historical context of these objects. When is something missing, for instance? When should something have been mentioned differently than it actually was? So research that is being done on such collection in terms of biases is a very complex endeavor. And because these collections are so big, our project's question was, how can we bring computation in? to help both with these complexities, so to try and contextualize maybe, or try to fill in missing information, and to just help with the sheer amounts, because just amount wise it's too much. So with this in mind, the question was at first is, or sort of for AI people, the most obvious question is, and maybe even for other people, is can we devise algorithms, can we devise computer tools that can automatically help flag biases and quantify them and explain them for the researchers? And sort of most of the rest of my presentation is actually going to be about why this is not a good idea. This is also why the question defining bias. Should we do that? Does that make sense? Is that a good idea? Now, one of the first definitions of bias, one step back. Why even define it? Well, because for computers to be able to deal with biases, because computers, right, per se don't have any concept of anything. So for computer scientists, trade is always to very carefully define things so that then we can start to quantify them, formalize them, and write algorithms that can eventually recognize them automatically. So one of the first definitions of bias that I came across, quite old, from the 70s, I think, just to show that sort of bias, it's a very hot topic in AI at the moment, but apparently already back then people were thinking about it. This was quite a seminal paper, by the way. And these two authors, they defined bias as when discrimination happens in a systematic and an unfair way against certain individuals or groups in favor of others. And so while this is probably a good definition in the sense that it's very broad, it captures probably most of what we would intuitively call bias, or what we would say bias falls under. The problem that it has is that it's a bit too vague. It's too broad. We can't really use this definition to devise algorithms yet. So then what we also did is we asked researchers on the collection, and not only on this collection, but also from other museums, researchers that try to find bias on a daily basis, the ones also that I mentioned earlier, to give their working definition of bias. Because my thought was, okay, if you have to find it as a human, then surely you'd have a definition of it. Turns out that was a bit naive, maybe on my side. But it also showed a very interesting aspect and sort of the core aspect of what I'm going to be talking about. Namely that we got 40 responses from people on what their working definition of bias is. And of these 40 responses, we got 40 different ones. So that also just goes to show that bias is a very broad, a very big category that is very difficult to define in the first place. I mean, I guess we all expected that in a way. And that people, when they talk about bias, they focus on bias in very different ways, and they have very different ways also of approaching it. This could depend on their own perspective. This could depend on what they have in mind when they talk about bias, agenda, and so on. You can imagine it. But what this means for us is that if we are supposed to develop a tool for researchers that can automate, their work in finding biases, so automatic bias recognition or quantification, such a tool will not be very useful, because if we use 1 or 2 or 3 or even 10 of these definitions that we got from researchers, and not the other 30, the other 30 researchers will not end up using our tool because it's not according to their definition. So that also just leads to a very practical problem of, even if you have a definition that you could implement, is it one that other people will also agree with? And then will that lead to them not using your tool or disagreeing with the outputs of your tool? And it kind of turns out that this is a fundamental problem for how AI is dealing with bias at the moment. So bias, as I said, bias is quite a hot topic at the moment in AI. And so in the first paper, Language Technology's Power, was written in 2020, and already at that point, they'd found 146 papers that were just on bias in natural language processing, which is quite a lot. And so most of these papers focus on one of two things, either trying to find out biases in machine learning models, in AI models, and then try to debias them, or use modeling techniques to find biases, and by that they usually mean some kind of statistical imbalance. So some kind of skewed association with models. And the problem that, so this first paper that I'm citing, the problem they found was that what most practitioners in AI do is that they use quite ad hoc definitions of biases. So when they talk about statistical imbalances or bias in general, what they'll end up doing is just come up with an intuitive definition on their own, not actually citing any social sciences or philosophy or other relevant research. I'm quite willing to bet that if you go out now and you Google bias AI and you click on the first paper that you find, you will not find a single philosophy or social sciences paper cited in there, which I and also this paper find quite problematic. And what it eventually leads to is that we have 146 papers that all have their own intuitive definitions of what bias is, but they're mostly vague, they're mostly inconsistent, and they can't really be brought together either in a way, like compared in a meaningful way. That's problem sort of number one. And then problem number two, that's the second paper that I'm citing, the use and misuse of counterfactuals in ethical machine learning. And what they're talking mainly about, and this is also something that I very much agree with, is that the way that bias is approached in AI at the moment is quite reductionist, because all of the definitions of bias, all of the ways in which bias is addressed in AI relies on social categories. Now, for instance, and this is probably the most prominent example in AI at the moment, a paper will focus on gender biases, and then they will categorize the entire world into male and female. This is what they mean when they say reductionist, right? And then bias in this sort of way that is researched will be whether certain professions are more associated with men than with women, or whether there are imbalances in representation between men and women, or well, the categories of male and female, I should say. But as these authors note, and others have as well, and sort of the problem that I take for my research is that this is quite reductionist, as I said. So what you'll actually probably end up doing, as these authors also note, is that you'll actually probably more entrench the problem even more, right? Because addressing biases in AI, this whole literature is supposed to be about making society more inclusive, also making the digital world more inclusive. But what they actually end up doing is they end up excluding groups again and sort of marginalizing them again. So these are sort of the two practical problems from within AI that I find problematic when sort of looking towards AI and sort of what's currently going on in the computational fields for trying to automate bias research. And just to bring it back, to automate bias research so that museum researchers can sort of be aided in their daily work. where, as I also said, and I hope you also agree, yeah, computational power could really be useful because of the vast amounts, just to reiterate that. But then I would actually like to go one step further, because to me and to some other people, there is sort of an even deeper problem, and you could maybe argue that these practical problems in AI that I just mentioned, you could argue that they maybe actually stem from this very deep problem.
Sorry,
yes.
Valentin, we have a comment in the audience.
Yes, please.
So Tibea Herzl says, I'd recommend to approach this from the definition of truth in Plotinus and solutions on the Cattian gap. You can look in my research for relevant references.
Okay. Could we maybe address this at the end, because this one seems like a bit of a deeper discussion, something to not be addressed right now. So yeah, the person who asked this, if you could stay around and ask this later, please.
They say sure.
Cool. Perfect. I'm really intrigued, actually. So yeah, for this, I would like to look at feminist epistemology. Just to be really explicit, this is probably not the only sort of strand in philosophy that has come to this conclusion. I'm not sure, to be honest, I'm not a philosopher. But I'm just mentioning sort of as one example of where the core of the problem could come from. And so one of the core, or maybe the core assumptions of feminist epistemology is that all knowledge is always situated. By situated, they mean that knowledge is embedded in a person, for instance, probably mostly a person, that has a historical context, that has a certain agenda at this point in time. So situatedness is also really closely tied to perspective and standpoint. And so in a way, every standpoint, every perspective could kind of be said to be unique, because of its tightness to a specific situation that is about time, that is about context. And so it can usually be assumed that these will not sort of repeat. And so because knowledge is situated, then research must also happen from these standpoints, right? Because research is about knowledge. That's at least what epistemologists would probably claim. And so if research happens from standpoints, then of course research into biases also happens from a standpoint. And so now this is sort of where the problem comes in, because that means that that humans will probably have to do bias research, or that if an AI does bias recognition and we see that as research into bias, which I would definitely argue that it is, then this would happen from a standpoint. But I think personally, and so do some other people, currently to say that AI has a standpoint is a bit weird. Because AIs can't really deal, I mean, this is also kind of a famous problem in AI at the moment, it is this sort of lack of perspective in AI, that AI is always just about majority votes, about taking the mean over different perspectives, so that AI doesn't really have or represent a standpoint. But then if bias research has to happen from a standpoint, because knowledge is situated, we get a clash here. Further, feminist epistemology argues that, and this is specifically about research into biases, this could probably also be said about other things, I'm not sure, to be honest, is that bias research is equivalent into research into power structures, right? Bias research doesn't just happen sort of quote unquote in the lab, but bias research is also a social act. So while you're researching into bias, you're also kind of looking at society at large and looking at, okay, what power structures do we find here? And actually, also interacting with these power structures. So it's also kind of impossible to do bias research without doing something with these power structures. And so here again, we have a problem with having AI do that, because AI is not really embedded into these power structures. That's probably a very complicated problem, but it can't really fully interact with power structures that are sort of part of society, where AI is sort of next to society. And then finally, feminist standpoint theory very specifically argues that the groups in society that are marginalized, so the groups at the margins of society, that they are actually at epistemic advantages of seeing bias. Now, because AI again represents majority standpoints, because it can sort of only represent what the majority thinks, it has no access to the perspectives of marginalized groups, and is therefore, if you believe the feminist standpoint theory, at an epistemic disadvantage. So these are sort of the problems for dealing with sort of bias in AI that would come from feminist epistemology. And what we took away for our project from this, and also the previous points, is that we really shouldn't be doing bias recognition with AI. We really should, at least we, I'm not saying that, no one else should, but we concluded for ourselves that we should steer away from what the majority of AI is doing at the moment, in trying to really automate bias recognition and bias quantification, sort of in this blind way, just treating bias as sort of another problem to be solved. Now, of course, the question becomes, but then if we're not allowed to sort of do that, then what are we even allowed to do now? What can we still do? And so this is where then we started to take the name of our project really seriously, especially the observatory part. Because I think, and here I also cite a paper that has a similar idea, that can actually be a way to sort of go around this problem. So the core of the idea is that rather to do the bias research for the researchers, so really rather than trying to automate some of their steps, all you do is you build them an observatory. And so the way that this paper that I'm citing, it's called the thick machine, anthropological AI between explanation and explication, phrases this, is actually from anthropology, where there has for a long time in the tradition of anthropology been a distinction between explanation and explication. And so I'm not really going to explain what these two terms mean, but I just want to say that explanation is sort of more what AI is trying to do at the moment. They're trying to imitate the human researcher, basically, in their work, where the human researcher would go through a data set and would try to flag instances of bias, would try to come up with quantifications, would really try to understand how bias in this certain data set works. So that's kind of the explanation side. And what they're arguing for is that there should be a shift away from that and towards explication, and where explication can be understood as just pointing out where are the examples that a human should be looking at if they are to do bias research, right? This paper's research was done on tweets, and they were trying to predict emoji reactions. And so what they argued was basically, with hundreds and hundreds of thousands of tweets every day, all day, if a human researcher was trying to figure out patterns in how emoji reactions happen to tweets, what the AI should be used for is not try to do that too, so try to predict what the emoji reaction would have been, but instead basically do a filtering task where most tweets are probably not very, very interesting for the human researcher to look at while they're trying to learn something about how emoji reactions happen. And then the AI sort of only highlights those examples that are interesting to look at. This in anthropology, this is then called a thick description. So objects that warrant a thick descriptions are those where the relationship between the context and the behavior is not straightforward. So in terms of tweets, you could say, for instance, if someone tells a joke and then you get a laughing emoji, that's not an interesting situation because that one's easy to predict. If someone says something that concerns irony, or someone uses political sarcasm, and then you get a whatever frowning emoji, that could be an interesting case, because now it's difficult to say why was that the reaction, and this is what they mean with a thick description. Now it's actually interesting to try and describe why that happened, and so what they're saying, and they actually also showed this in their experiment, that it really works quite well if the AI is only there, to point to the examples that are relevant for this research and discard everything else. And so the reason why this is still useful is really just the sheer volumes of data that we're working with, right? In our case, 800,000 objects, it's really hard also for researchers to decide where to begin, right? What objects to look at first and which objects to look at last, when they're trying to research bias as a whole, but also trying to answer specific questions about bias. So the point here, what they're arguing and also what we're arguing, is that there should be a shift to just highlighting those data points, those objects that researchers should be looking at. And now I'm going to go into some examples because we already built this tool. Just a word of warning, it's more like a proof of concept tool. So it's a bit minimal sort of in what we did. And I also want to explicitly say that you could have also done lots of other things to build such an observatory, right? To try and highlight objects to researchers that they should be looking at. But yeah, I'll walk you through some examples, and I hope that it then becomes clear sort of these tenets that I just talked about, sort of this way of approaching the whole problem, how we then designed or how we restricted the choice of algorithms, how we designed algorithms to respect that, and vice versa, how this led to sort of the whole conception of the tool. So this is a screen. I'm going to go into screenshots. It's actually already available online. I can't share it because of privacy issues, but I'm also not going to do it live because it's quite a big tool and it tends to deplete my computer's resources. So this is a screenshot. And what we have here is basically a subpart of the collection. Let me actually skip ahead because there's annotated. So we had 140,000 objects in total. And if you search for the word plantage, which means plantation in Dutch, you end up with roughly 1,500 objects, 1,600. And each dot in this graph here is an object in the collection. Now, the x-axis of this graph is these are categories that are already present in the collection itself. And so these are also categories that would usually be sorted by researchers. So for instance, you have date, you have department, you have geographical location, and so on. And so what we then do, and this is sort of all that we do, is we add this y dimension to sort of indicate there could be some potential for interest for bias going on here. So how do we do this? We have a bunch of algorithms. This one is the so-called Typicality Engine. It does something with probabilities. It's not that important right now. What's important is that it scores each object, and then, as I said, puts it here on this y scale. And so, as you can see, for instance, here, this is actually one of the problematic terms that also appears in the Words Matter publication. This object receives a relatively high score because apparently its language is typical for the collection. It's typical language within the collection. What's really important though is that this, and this is also kind of the point of everything that we're doing here, is that this algorithm, this scoring algorithm, has no concept of bias. It doesn't make any reference to any social categories. It literally just computes the language modeling probability of a description in the collection, right? So it does this completely without any reference to biases, categories, or whatever. And so that was kind of the important point to us, because in that way we can sort of ensure that what researchers look at, what biases researchers find when they look at this, they really came up on their own. They weren't sort of influenced by whatever conceptions of bias we have, because we don't have any. We didn't build any in here. Now, of course, you could argue that, you know, this thing brings in its own biases, and that's fair. But I guess you can't avoid that fundamentally, right? Whenever you deal with data, you're going to bring in some biases, because, well, otherwise you'd have to be invisible. But I would argue that sort of this is how we minimize that influence. Another example is what we call the content length engine, which is an example of an algorithm that does this kind of scoring, so that highlights objects for people to find them more quickly, or you know, objects that could be interesting for bias research. This algorithm is an interesting example to me because of its simplicity. Because what it literally does is it just counts how many words there are in the description of an object. So what you see up here are all the objects that have long descriptions, and down here all the objects that have short descriptions. Now, why could this be interesting? For instance, and I searched for the word Kunst, which is art in Dutch. In the Africa the department that this museum calls Africa, I should say, objects that contain the word Kunst tend to have rather long descriptions. In the department that they call Japan and Korea, these are rather in the middle. So again, we're not saying what is bias. We're not saying there's a bias toward art in Africa or anything like that, but we're just pointing at sort of statistical, not even necessarily statistical, but we're just pointing at properties in this collection. This is another algorithm that is probably the most useful one at this point. And that one actually does have a concept of what bias is, namely it counts in each object how often do the words in this list occur. And these are actually the lists. I mean, it's a bit extended, but these are actually the words from the Words Matter publication. But still, why it's kind of flexible towards whatever standpoint on bias a researcher brings in, is that you can edit this list. You can freely bring in your own. You can edit as much as you want. This list is really just there sort of as an example. So yeah, what it does is it takes this list, and then in each object it counts how many times do the words from this list occur in the object's description. So it's kind of like a relevance, a very simple relevance algorithm. Another one that we have is word associations. That one also gives quite interesting examples. So it just measures how strong are the word associations between all the word pairs in a given object. And so, for instance, this one finds that there's a relatively high association strength between mooi and vrouw, which mean beautiful in Dutch, respectively. Beautiful woman in Dutch, respectively. And again, we're not saying, I mean, now I'm me as a human, I'm identifying this as a potential bias, but the algorithm doesn't do that. The algorithm just says there's this word pair here, it scores relatively high, so beautiful and woman are relatively highly associated. Not because this algorithm had any access to what bias is, but just because this data set happens to be like that. And sort of also, right, that's kind of where you see the idea here, is that biases will reveal themselves almost through these kinds of algorithms. The last one that I want to show, this is what we call the random engine, and what it literally does is it gives random scores to algorithms. And the point of this one is that this was also actually brought to our attention by the researchers in the museum. And I think it kind of also neatly connects back to all the philosophical tenets that I was talking about, is that there's also really high chance for computational tools to be disruptive in bias research. So there's high disruptive potential, meaning that if researchers are, and of course that's always the case in any field, I would argue, if researchers always move along the same paths of research, then computation also has the power to actually kind of kick them out of that, and sort of be a disruptive force to kind of force them to maybe look over there where they wouldn't usually look. And so the random engine, I mean, I realize also that it's a bit silly because it's just random scores. So you could also do this sort of in a more nuanced way. But just as a very simple example of how disruptiveness could work, namely by just highlighting random things, right? And then, for instance, in one configuration, I found this object, which maybe, based on its description, is not that likely to be looked at, because it seems like, quote unquote, a sort of benign object. But it again contains this woman and beautiful trope that we saw highlighted before. And so this object would have actually also received rather low scores in the other algorithms. So this, yeah, just also as an example of sort of that, yeah, algorithms could also have sort of this other nature. They not only to highlight and do what we expect, but also to sort of lead to the unexpected. I would like to conclude the presentation part here. These are references and definitions of algorithms, and go to the discussion. So there was already one question at least.
Yes, I can definitely get back to the comment. 1 second. So to repeat it, said I'd recommend to approach this from the definition of truth in Plotinus and solutions on the Cattian gap. You can look in my research for relevant references. And they also added, just to add to my former comment, anthropology is the most serious issue because almost all, luckily not all, research in this field is still biased on representative methods, and there is no useful outcome in anthropology which can be researched in this way. You need a non-representational research in this field. Everything else can only contribute to data collections and accumulation. They shared a link as well. I can share that in the comment section again.
Okay, that seems like a rather strong stance. I'm honestly not sure how to respond to that on the spot. I don't know, maybe someone else would also like to say something. What I would like to say though is that whether or not anthropology actually does contain answers on bias, or what that is, or how we should approach it in society, that I would like to sort of, that's sort of not, for me, that's not my question, because I'm a computational scientist. What I just wanted to point out with this presentation sort of, or this project as a whole, is that it's important for us to look at anthropology and philosophy for definitions, for problems also in how we approach and attack things. Because to me, that's really the big thing that was missing in AI at the moment, and the thing that makes AI as a whole, sort of as a field that's trying to address this, not inclusive, and not responsible. I saw you raised your hand, Tabea, right? If you want to say something,
Yes,
please.
can you hear me?
Yes.
Oh, wonderful. I will try if you can see me. Oh yeah, it's working. Hello, everybody. What I did not want to argument or anything. That was my argument in my research, because
Okay.
I was actually developing a software to analyze anthropological phenomenon. So I had to deal with this question: where is the difference between AI and the person? Originally, I came from a very simple topic. I wanted to define peace, which I found out, yeah, so far nobody had actually done that. Everybody defined peace in negative terms, like what it is not, like absence of war. And I come from, in my practical life, I'm doing a lot of project management, so I wanted a positive definition. You have that also in program. You cannot achieve something if you do not have a target. Just avoiding things will not bring you anywhere. So this was more my approach, which is apparently not very popular in science. And it brought me to the problem. I need to define what a person is to understand what peace is, because peace is a human being, not a thing of human beings, but of persons. And I worked within argumentation ethics, discourse ethics. So I know about this thick description and all these kind of things. And I do not have preferences, actually. I tested all these methods, but they were not working out. That was the problem. I was really hunting down to the personhood, and you cannot find what really makes a difference between what makes a person and what not. And I worked with, at the end, I had to use material that existed, and I used very famous anthropologues and philosophers, but they came always to the same point where they just interrupted their the reasoning and said, well, I cannot say why, but persons can only be human beings. But then that is the point where they ended being scientific. And I'm not a monotheist. So I came from the animistic viewpoint and said, okay, but my viewpoint is equally strong that this is nonsense. I mean, this is even not a viewpoint, this is an experience in life. So I said, how can we make that scientific? Because it's not about you are right or I'm right. There is an issue, because we have this issue now: when is a robot and when is it a person? Because being a person means having human rights, for example. Yeah. This was a serious question. Right. And this was the whole process. And I cannot explain now in 2 words why you cannot use any representational science, but in a resume is you cannot represent reality. Being a person is a transcendent experience. It is not a scientific question only. It's something that goes beyond science. So with only objective analysis, you cannot catch a person, because there is a part which goes beyond the physical body, beyond the brain activity, and beyond all the biological parts. And that's the reason why.
Sorry, can you say something about how that relates to addressing biases in AI?
Oh, well, that you are doing a very good work, as I see so far, because no, really, because you are not saying actually this is a bias. You are somehow offering really a platform to engage in this kind of performative research. Yeah. Because what we can do now is we can see, okay, I'm not sure, somebody else asked that, and you will probably answer right now the question, how you use the logarithms to find out what comes up. If that is probabilistic, if you're counting what comes up more often, and so on. But you visualize, you make it visible to the human eye what is in the words. This is more or less what I'm doing with my software too, actually. Right. And then you can see which terminology is used, because we have also the problem that some words were not considered sexist in the past, but they are now. But it's not because we are less sexist now, it's because the meaning of words also shifts. So you can never for all eternity say this is a bias or not. No, exactly. What you can make is visible, and perhaps in 100 years we can even compare your data with data of future researchers and say, look, this is how it looked in 21st century, and this is how it looks now. So I think this the right track. Yeah.
That's actually that's another big problem, is the staticness of the way that definitions of bias in AI at the moment are done, is that they really deal with like static definitions that are really tied to the right here, right now. And then who knows, in 10 years time, they probably don't really even make sense anymore. And that, I mean, okay, I have to also in fairness say, this was probably more the state of the art 5 years ago. It's getting better now because of course people are criticizing that and people are coming up with sort of
solutions. You can still Google and you find a lot of bias just by translating.
Right.
Yeah, it's true. You can translate certain sentences and it comes always up. If you translate, for example, nurse into Spanish, it's always the female version. If you translate, that has not improved. So
no, exactly.
Is that a bias? We should discuss these kind of things, but yeah. At the end, AI does what you program it.
Exactly. Thank you. Thank you. Should we, were there other questions? Just to give them some space as well.
Yeah, there was one question that Tabea was referring to from Antoine Isaac. How does the random score bring you this insight about the object, or is it your interpretation? I don't know if Antoine, you would like to speak up as well.
Yeah, I can try. Actually, I was really wondering how you came to see this object from the diagram that you constructed with those random scores.
Right. So the idea is that all of these algorithms, the higher the score, maybe that wasn't so clear. The higher the score, the higher sort of the algorithm is trying to say that there's likelihood, or there's likelihood that this object be interesting towards bias research, right? So also explicitly not the higher the chance that there is bias in this, no, but just the higher the chance that this object is interesting for research on bias, right? And so the random engine, it really just assigns random scores, and maybe that's hard to see, but it's this little point up here that corresponds to this object. Right, so in this idea, what researchers would hopefully do with this interface is then they sort of would skim off the top. I mean, they could also look at the bottom. That's up to them how they direct their attention. But we're kind of trying to say, look towards the top. And so that's what I did with this view. And then it turns out that, I mean, you're right in saying that, you know, whatever I said about this object, that was then completely my interpretation. And of course it had to be because this score is completely random. So there is also no sort of intent for this algorithm to point out this object for me, because it doesn't even look at the object. It just gives it some random score. Does it make sense?
Yeah, but then how did you find out that it was less likely to be considered, even though you are associating it with scores? I mean, there's the same thing with beautiful women in that in that data. So that's, I mean, so it's not only random. You also computed your other indicators, no? No,
this is completely random. It just pulls out random words. And assigns them random scores. So it's really everything in here is random.
Okay.
And that was actually interesting because we showed this also to some researchers and then and also to the head of the collection. And I didn't. It was a bit unfair because I didn't fully divulge to everyone that in that session that it was just completely random. And then people started to be like, oh yeah, look, this is here because this and that and this and that. And it was interesting also how people apply interpretation to something that was completely random, right? That was also an interesting observation there. But yeah, so really, in this engine, there's nothing going on. And again, like I mentioned, it's not. I realize that it's a bit silly, or I realize that that's not, you know. I wouldn't encourage people to really look at this very much. It's more just there to make a point. Let's say that.
All right. Point made.
Does that help?
Yeah.
Are there any other questions or anything else you'd like to discuss? We have 1 minute left as far as I see.
Is this accessible online?
It will be as soon as that's a good question. It will be as soon as we've cleared up all the privacy issues around the data set. So the software is completely open source. So that is being made public. I'm currently wrapping up this project, so that's why it's also not there yet. But the problem is in the data set of the Museum of World Cultures. So I think what we'll probably do is we'll host this somewhere, but not include that data set, but only public ones, and then it can be fully public. So the answer is mostly.
Nice. And you have one comment from Sitada Samad, who says, wonderful presentation. Looking forward to hearing more about SABIO. I'll definitely stay tuned. Thank you and best regards.
Thank you very much.
I see Antoine has raised your hand, or?
Yeah, well, just one last quick comment. If you want to publish it with some data, maybe you can run your analysis with a couple of indicators on some Europeana data sets. In principle, we can use entirely what's in there. If you want to illustrate without, I mean, maybe you can publish without diving too much into some interpretation, as you've done it for those dirt collections. But yeah, showing some stat. If in the end it's about showing how the tool can manifest some properties of the data, then you could try it with any data set that's open.
Yeah, that's kind of also how we built it. Yeah, to really try and make it as agnostic to dataset properties as possible. We have the open built-in dataset, which is a part of the Sound and Vision collection here in the Netherlands. That's fully open. We have actually been thinking about the Europeana collections as well. Now that you mention it, thanks for reminding me of that.
Well, you know where to find us.
Yeah, exactly. Thanks.
Thank you all so much for joining. Thank you, Valentin.
Thank you for joining. Thanks for having us.